For this next section, we're going to talk more about angles and triangles. First, let's focus on some vocabulary that we will need for this section. The first is interior angles. Interior angles. So interior, if you think of like the interior of a car, you kind of think of inside. These are the angles that are inside a polygon. So when you look at this first example of interior angles, you'll see that each of these red shaded pieces are angles that are considered interior angles. So just opposite that are exterior angles. So these exterior angles are the angles that are on the outside of the triangle. So when you look here, that's these angles that are not on the inside of the triangle. I'd like you to pause the movie, copy the definition down for interior and exterior angles, and also draw these figures so that you see the difference between the two. Play the movie when you're ready to move on. The next thing we need to know are that the interior angle measures of a triangle equal 180 degrees. That's kind of a mouthful. Let's think about it. Today in class, we used our triangle that we drew, and we cut up each of the angles of the triangle, and notice that they all can lay out on a flat line, or 180 degrees. If we want to write that algebraically, we can say that a particular angle is x, another y, and another z, and that x plus y plus z equals 180. I would like for you to copy this down and this into your notes so that we can see algebraically how the three angles add up to 180. So let's try some practice problems. If I know that all three angles add up to 180 degrees, I can use algebra to solve for x. I know that this first angle is 90 degrees. So 90 plus my next angle, x, plus my last angle here, x plus 28. I learned in the previous slide that all of these equal 180. Well, let's go ahead and combine like terms. So I know that I have x and x, which would give me 2x, and I have 90 plus 28, which would be 118, and all of that is going to equal 180. Go ahead and solve the rest of this equation on your own, and then press play to check your work. Let's see how you did. To solve this, I'm going to subtract 118 from both sides. So I now have 2x is equal to 62. Inverse operations say I divide both sides by 2. 62 divided by 2. Well, I know 60 divided by 2 is 30, and 2 divided by 2 is 1, so x must be 31. Pause the movie and copy this sample problem into your notes. Now sometimes we will solve for exterior angles. So in this one, we're solving for x, which is on the exterior of the triangle. Well, again, this is like the problems we've been doing, trying to solve the puzzle. If we find out what this angle is, I know that these are supplementary angles, and I should be able to find what that is. Pause the movie, try this problem on your own, then press play to check how you did. So let's see how we did. I'm just going to go ahead and assign this first y. So I know that 36 plus 72 plus y is equal to 180 because all three angles in a triangle add up to 180 degrees. So let's go ahead and add together 72 and 36. 72 plus 36 is 108. So 108 plus y equals 180. If I subtract 108 from both sides, let's see, 180 minus 108, I've got to borrow, I should get 72. So y is equal to 72. But I'm not done. What I've really found is this angle measurement here, 72 degrees. Now I apply what I've learned about angles. I know that 72 and x make a straight line. That means they are supplemental angles. So I know that 72 plus x is 180. So let me take that 180, subtract the 72, and I can see up here, since 180 minus 108 is 72, well, 180 minus 72 must be 108. Some of you might see a shortcut there. So x is actually equal to 108. Copy this problem into your notes. Here's one for you to try on your own. You are going to do 2 homework check problems, this one and the one on the next slide. When you're finished with both of those problems, go to Schoology and submit your answers for this video lesson. Here's your last homework check problem. Solve this particular problem for y. Once you've finished with problem 1 and 2, you will submit your answers into Schoology.